There exist protocols. There exist protocols that are normally used for network management. Now, at this particular moment, network management involves so many protocols that we are going to learn today, and we will learn of also some of them later on. So welcome back to this particular chapter. We learn about a few things we might have mentioned or probably not. Protocol like CDP, which is the Cisco Discovery Protocol. We have LLDP, which is the Link Layer Discovery Protocol. We have NTP, which is Network Time Protocol. We have SNMP, which is a Simple Network Management Protocol. We have the Syslog services. And then we also gonna be talking about how to backup our configuration files and the IIS files, okay? And basically looking at some protocols that can be used to manage our network. So a couple of protocols here, very new, but majorly used for network management, Now, so first and foremost, I would like us to talk about CDP. This is it's a device discovery. What do you mean by device discovery? That is done by the Cisco Discovery Protocol. So this particular protocol, basically what it does is this. Let's say that you have this router here, and we have another Cisco router here, and we have another Cisco switch here, and we have other Cisco device here. So what Cisco Discovery Protocol does is that Cisco Discovery Protocol, when you enable it on all these devices here, it basically discovers so much information about these devices. Okay, it discovers so much information about these devices. And when you say, for example, show CDP neighbors, you are going to learn that from one of the devices, let's say this router, you will learn like what are the IP addresses, what are the types of interfaces, what is the name of the devices within the network. So it will basically be mapping and giving you information about other Cisco devices available in the same networks, okay? So CDP is normally implemented within routers, switches, and servers, And the devices keep on exchanging at CDP advertisements, okay, and sharing information about the different devices. And that is what we are going to be learning today. Now, it's very important. I mean, it's very easy on Cisco devices to enable CDP. Of course, it's important to also learn that it's always enabled by default, but you can disable it and you can also enable it back. So CDP can be enabled either on a per interface, or it could be enabled globally at the global configuration mode for all the devices, okay? Either you enable it on one interface, or you enable it on all the interfaces at the same time. So if you want to enable it on an interface, you go to that interface, for example, interface G00, and you say CDP enable. By enabling on that interface, it begins to send CDP advertisements to other CDP enabled devices. If you need to disable it on that interface, you say no CDP enable. If you need to enable it on all the interfaces at the same time, you go to the global configuration mode and you type CDP run at the global config mode. And of course, to disable it, you say no CDP run. If you want to display interfaces that have been configured with CDP, you just need to say show CDP interface, for example, G00. So that is CDP. Now, if you want to display information about other Cisco devices within that network, the command is clear. You will be able to see so many things. So for example, when you go to R1 and to say show CDP neighbors, you will see down here that one of the devices connected to this network here is S1. S1 is connected to R1 through R1's interface G001, but the S1's interface is fast Ethernet 0/5. You'll see this switch is connected to our router. Its version is 3560 series switch. And for whole time, I think this is for how much time it's been connected. Its capabilities that it's a switch, all right, so on and so forth. So there's a different variation of this command, show CDP neighbors. If you needed to also see, and this is a common question for your exams, if you also needed to view the IP address of those other devices, you're gonna need to have show CDP neighbors detail. When you say show CDP neighbors detail, then be assured that you're also going to see an IP address as one of the details of the other Cisco devices. Now, hackers use CDP a lot, and that's why it is recommended that you only enable CDP when you need to use it. Otherwise, always disable CDP on your devices, because a hacker can be able to learn so much information from your devices within your network. So they just need, he or she just needs to be logged into one device, and that's it. They can now be able to map all your other devices. We have a sister of CDP. Since CDP is only for Cisco devices, we also have a standard protocol for discovering information about other devices, regardless of which vendor. We call it the LLDP, which is also used for discovery. So LLDP is the link layer discovery protocol. It's vendor neutral, but also a discovery protocol similar to CDP, okay? So it doesn't choose any devices, so it can work in routers, switches, wireless access points, on and so forth. So they also do the same thing. They send LLDP advertisements, exchange it among the devices. It doesn't matter whether they're Cisco or they're Huawei or whatever kind of devices. Just like CDP, LLDP can also be enabled on the global configuration for all interfaces. You start sending LLDP advertisements. You just need to say LLDP run. But if you need to enable it on a specific interface, then you're going to use two commands. So you get into that interface, for example, interface gigabit Ethernet 0/1, and you must say LLDP transmit and LLDP receive, LLDP transmit and LLDP receive, and you can be able to say show LLDP to view what you have already configured. If you now need to see information about other LLDP devices, just like in CDP, you'll say show LLDP neighbors, show LLDP neighbors. Of course, that will tell you which devices. Like you can see there's R1 and there's S2 connected on this switch interface, F05 and F01 respectively. Their whole time is here. And one is a router and B1 is a bridge. I mean, bridge used to be the name of the switch before the switch came. So the bridge is still popularly used for referring to the switch. The interface of the R1 connected to our switch is G001, and that of S2 connected to S1 is F01. So show LLDP neighbors. Like CDP, you can't see the IP address here, and you might need to modify that show command by saying show LLDP neighbors detail, show LLDP neighbors detail to be able to view some addressing here. All right. So that is very, very important. This is the router, and I don't think it seems to have any IP address. All right, that's okay. Now, having talked about CDP and LLDP, let's now have a conversation around NTP, Network Time Protocol. Now, ladies and gentlemen, it's important that our devices to record the same time, so that wherever an event occurs or a security breach occurs, and we collect log messages from our devices, they need to be recording the same times, okay? Now, normally the software clock on our routers and switches starts when the system boots up. So it becomes the primary source of time for the system. But like I said, it's important to synchronize time across all your devices within the network, okay? Now, normally the time can be set manually, as you can see here. You just need to say clock set at the privilege exec mode, clock set, and you put 36 seconds at 00 seconds, no, 36 minutes. So it's a 2036 at 00 seconds, November 15th of 2019. This could be, the manual way of setting time, but you realize that you can't set the same accurate time for all your devices. They're gonna have to be apart with some seconds or minutes or so. And so the best method to automatically or to synchronize the same time for all your devices is to configure an NTP on your devices, okay? Now, NTP is a hierarchical system of time sources, and it has different levels that we call stratum. So this key source time is called the stratum 0, where we get where the time source, the authoritative time source. And then the time is now distributed across networks by using other NTP devices, okay? But the maximum hop for NTP is up to hop 15. That means it can go up to stratum 15. I mean stratum 16, which is the lowest stratum level that a device could be synchronized to. Now, looking at how to configure NTP, if you need your router or switch to get time for a particular server, then because a device can be an NTP client or an NTP server. Now, to configure a device as an NTP client, you need this command NTP server, and then you put the IP address of the server from where you want this device to get time from, okay? But if you want the device to be an NTP server, then you're gonna need to say NTP master. Command is NTP master. So NTP master is gonna be making your device to be an NTP server. But when you say NTP server command and you put the IP address, you're actually telling this device from which device's IP address to get time from, okay? So when you say here, show clock detail, you'll be able to say the time source is currently NTP. The time source is currently NTP. And to view some of these associations, you can say show NTP status. If you want to reveal the status of your router, you can see that this device is receiving time. It's actually fast. It's a fast stratum. Stratum is fast, stratum 1, and it's getting time from a GPS reference clock, okay? And the address is actually 209.165.200.225. But, if you say show NTP status, this device itself, it's at stratum 2, okay? But it is associated to get time from a stratum 1, okay? It's getting time from a stratum 1, which means it is a stratum 2 when you view the status of this particular device, okay? And you can see the reference time IP is actually there. So that's NTP, and it's a very important protocol to have, especially for bigger networks. Now, yet another protocol, we call it SNMP, which is the Simple Network Management Protocol. Now, SNMP was developed to allow network administrators and security administrators to manage different devices within an IP network, okay? So it's always enable you as a network admin to monitor and manage your network performance, number one, network, find and solve network problems, and even planning for network growth. And you actually get to manage all your network devices here. And that's why SNMP has 3 elements. SNMP has 3 elements. The first one is called an SNMP manager. SNMP manager. An SNMP manager, as we are going to see, basically is just one of the computers loaded with the management software, the SNMP management software. Then we have SNMP agents, and the agents, these are the devices that are being managed within your network. And then we have the MIB, the SNMP management information base. This is a database which is always found within the SNMP agents. So basically, SNMP defines how the management information is going to be exchanged between the manager and the agents. Okay. SNMP uses UDP port 161. It's important to know, and that is for the agents. Then for the manager, we'll use UDP port 162. UDP port 162. So this is a clear example of how SNMP actually works. So this will be our SNMP manager that is loaded with the SNMP software. And these are our SNMP agents. These are our agents, and each agent contains an managed information-based database, which carries information about all these agents. Okay. Now, what happens is that there are three ways of communication between the manager and the agents. One, through the manager, you can actually configure some settings on your devices since you're managing them. And so the message, the messaging that will be sent when you need to configure something on these agents, you send a set message. The set message will actually configure something on our devices. Then if the manager needs to request for information, maybe the manager needs to view the routing table or check at the interfaces IP address configuration. The manager will send a get message to their client devices. And then if the clients receive a get message, which means they need to provide some information to the manager, the agents will send a tap message. Okay, will send a tap message to be able to provide the information requested by the manager. Okay. Now, it's important to note that there are three versions of SNMP. We have SNMP version 2, which is a very old protocol. You can see we call it it's a legacy standard. And SNMP's version 1 is very insecure and should never be used because of the security risks involved. But we also have version 2C of SNMP, which when you look at version 1 and version 2C, there's something they have in common, which is called community strings. And community strings, which are used for authentication, they're just plain text passwords. These are just plain text passwords. And that's what makes the two of them to be very insecure. Okay. Now, version 3 of SNMP, okay, which uses username authentication and provides both hashing and authentication. And it uses the HMAC, MD5 and SHA for hashing, provide integrity. But for encryption, it uses the DES, which is the data encryption standards, the TripleS, or even the AES, the advanced encryption standard. So the version 3 has very strong hashing for integrity and encryption for confidentiality. And that is what makes SNMP version 3 to be more preferred over all the other versions. Okay. Now, let's look at another small protocol here. We call it the Syslog. Syslog. Okay. Now, Syslog basically is actually a protocol which is used to normally to collect. It's normally used to collect notification messages across our network devices. Okay, so it's an event message collector within the devices, and it can be able to gather logging information for monitoring and troubleshooting. It also has the ability to select the type of log information that is required to be captured. And finally, it can specify the destinations of a captured message. It could go to the console. It will go to the Syslog servers available in the network, so on and so forth. Now, talking about Syslog, when it collects all this information, all these messages that are generated by the network devices, okay? Every Syslog message contains some kind of severity level and a facility. And that's what I want us to talk about at this particular time. Okay. Now, the smaller numerical levels will have more attention to be given because they are more critical than the higher numerical numbers. Okay. Now, this table is actually showing us a complete list of the severity levels. So what I'm saying is that the smaller the number, the more critical it is, and the higher the number, the lesser critical it is. So we have level 0 is emergency, level 1 is alert, level 2 is critical message, and you realize that the emergency means the system is unusable. When you say level 0, that emergency system is unusable. When you see level 1 alert, it's an immediate action is needed. Level 2 is critical, which means it's a critical condition. Level 3 is an error, so that's an error condition. Level 4 is just warning. Level 5 is just a notification, but not very significant. Level 6, just for the purposes of informing you, provide information. And level 7 is for debugging, and basically for debugging, normally for troubleshooting, so on and so forth. Now, every message is always displayed in a certain format. For example, all the syslog messages will always be presented in such a manner. Okay. So it will always start with a percentage sign here. Okay. And then it will follow what is called a facility. Facility will tell us exactly on what part of the device. It could be a link. It could be an interface. Okay. It could be whatever part of it. So here, the facility is the link in this case, and we're going to see more of them here. Then followed by a number here. A number is the severity level. And I'll give you, by the way, a very short mnemonic for mastering that particular table there. Then the mnemonic is what happened to that link. It must have gone from up to down or down to up. And then the description will follow after the colon here. An interface port channel 1 has changed step to up. Okay. Now, so that's how we read them. So the facility, then most important thing is always the severity level, because that tells you what kind of priority do you assign it. And then of course the mnemonic is there and the description. Now, to master these particular severity names in order of the arrangement, there's a mnemonic that goes something like Emma always cries even when nobody is dying. So Emma will be emergency, always will alert, and remember to count from 0. So Emma always crying, critical, even is error. When, and remember, emergency is the first one, so there's Emma and there's even. So Emma always crying, even when is warning, nobody's notification, is informational, debugging is, yeah. So mark that, and that could help you to remember it someday. By default, these messages do not always have time on them. They're not time stamped. And it's important to always have notifications to have a timestamp. For example, if you want to shut down this interface G00, it will give us, you see, it's giving us a syslog message here with a severity level of 5, but it doesn't have any timing. So if you want all your syslog messages to have timestamps on them, at what time were they generated, you need to go to the global config mode and say service timestamps log date time, service timestamps log date time. And so when we activate that interface again, interface G00, it's going to now be able to give you time. This is March 1st at 11:52 at 42 seconds. Okay. And so that is very, very important for us to see that. Let's look at router and switch file management. It's always important to manage your files, whether it's the user the startup configuration file, or it's the running configuration file, or it is the IIS file. Okay, so routers normally have different file systems, and you can see so many files. If you say show file systems, you'll see some very familiar file systems here, like the server file system here for HTTPS. There's an FTP file system. There's an NVRAM here, Syslog here, TFTP, TAR, NAL, USB, the boot flash system, so on and so forth. So it's important that, to realize that the operating system, the IIS for Cisco, can actually allow you to navigate to different directories and list the files within the directories. Okay, and you can also create other subdirectories within the memory. Okay, now it's important to note that using the command dir, just as we use in Linux, you can actually be able to list the contents of the flash memory. Okay, and this is normally the name of the current IIS file image that is running, the one that is stored on the flash, okay? So you can be able to see so many other file systems here available within our flash memory where the operating system is actually stored. Now, some operating systems, some routers actually, they come with a USB port, okay, which is basically a storage feature which can enable certain models of the Cisco routers to support a USB flash drive, okay? And that can always act as a secondary storage capability and for additional boot device. Now, if you plug in a USB storage device on this USB port, using the dir command, you can be able to view the content within the flash drive available there. Now, the most interesting thing is that you can also use the USB to back up and store some of your configuration files. For example, if I need to copy my running configuration file to my flash drive, I just need to plug in the flash drive, then use this command at the privilege exec mode. Just like we always say, copy running -config, startup -config. This time around, you're going to save it in the USB flash drive. So you say copy running -config, and the destination will be USB flash 0 and put a colon. And of course, if it asks for the destination name, you can name it R1-config and press enter, and it will definitely be able to do that. It will definitely be able to carry that traffic. Now, it's very important for you guys also to learn that password recovery procedures are very, very important within your network and within your line of career. We know that we configure passwords to prevent any unauthorized access, but sometimes we will enter our passwords, but then we could forget the passwords, and you need to have some best practices for password recovery. So these are the steps that are normally available. One, you need to enter the Roman mode. I'm gonna show you how to do that. Then you need to change the configuration register. then you need to, once you change the configuration register, you're actually going to cheat the router so that you are going to log in with the wrong configuration register, which is going to allow you into the executive, the privilege configuration mode. Okay. So once you are at the privilege level, you need to copy the current startup configuration to become your new running configuration, so that you can now be able to change the passwords on that new running configuration file. And then you need to copy that running configuration with the changed password to become the new startup configuration, so that when you reload the device is actually going to now use the password you have changed. So it's a very, very important step of learning. Now, as the router is just starting, or the switch is starting, you need to continue pressing. Most devices, you continue pressing the control key on the keyboard. So keep on pressing the control key, and your device is going to display the Roman mode. So you might not see switch and greater than sign. You are going to see Roman 1 and greater than sign. This is what we call the Roman mode. Okay. So you use the break sequence by using the control. Keep on pressing control during the boot up process. Or if it's a router, you need to remove the external flash memory when the device is powered off, before you can be able to enter the Roman mode. So once your device enters this mode, this is the mode that we need it to have. So at that point in time, we need to change the configuration register from the normal one. We need to give it a wrong one. So the wrong one is actually the one we are giving here. So we are changing it to a false. Okay, a false configuration register, which is going to cause the device to ignore the current startup configuration file. That is the very objective. Okay, you want the device to use a wrong or a fake configuration register, the one which is 0x2142. I think the other one is 0x2102. We're gonna see that. So make it to have to use a wrong configuration register by saying config 0x2142. Then you need to reset the router. Is like rebooting the router. So the router is gonna be rebooting, and as the router reboots, it is going to take you straight to the privilege exec mode without asking for any password. Okay. And that point in time, you need to copy the current startup configuration, which is having the password, and copy it to become the new running configuration. And then from there, you can now be able to change the password. Okay. Please here, do not say copy running config, startup config. You say the opposite. You now copy the startup configuration, which is currently having the password, to become the new running configuration. Once you do that, change your password, because you'll be in the privilege exec mode. Change your password, and you can configure any other password that you'd like to change. And once you do that, by of course saying enable the secret, and you put it Cisco, something you can remember. And then you now need to change the configuration register to the correct one. Okay. After the new password is configured, change the configuration register back to the usual one, which is 0x2102. Okay. Once you change it, so here now you don't say config, you now say config-register, and you put 0x2102. Then you go exit back to the privilege exec mode, and you now need to copy the running configuration, which is having your newly configured password, to become the current startup configuration password. And now if you reload your device, it will now be having, you shall have been able to change that particular password. So that is a very, very important skill for everyone to have. You never know. Sometimes you're just typing that password, and by mistake, you end up probably typing a spacebar after putting the last password. And a spacebar is also a character. When you press the spacebar, it's a character when you're creating a password. So because you don't want to make some of these mistakes, you need to know how to basically be able to reset that. I want us to talk about the last thing. We have talked about how to manage the startup configuration file, the running configuration files, how to manage the passwords. let us now be able to check iOS management. How can we be able to manage? How can we back up our operating system so that when your router or switch crashes, you still have some backup to be done? Now, we realize as a network grows, the Cisco operating system, the image and the configuration files, you need to store them within some central server, and we choose TFTP for this. So this is, of course, going to help you to control the number of the operating system images and their revisions, as well as the configuration files, which is the startup and the running configuration file. You can back up them up. Now, because in production networks, they occupy, they're within very large sizes of networks, and they have so many routers and switches. And so it is good practice to always keep backing a copy of your images in case that the image of the router becomes corrupted, or it's erased, or it's corrupted, right? And so for widely distributed routers, you need to have a source or a backup location for your files. And TFTP is one of those servers that allows this image configuration uploads and downloads over the network. So you can actually do this basically over the network. So the TFTP server can just be another router, or it could be a workstation, or just any other host device within your network. So to back up your image files and to maintain, operations within a network without any downtime, it's necessary to have, some of these procedures well laid down. And this is going to allow you to quickly copy an image back to your router and to keep the network going wherever there's a problem. So the first thing you need to do is to need to test if the device is actually reachable. This device that you're going to use as your TFTP server, by pinging it, basically. Once you ping it, you need to verify the size of the image in a flash. So verify that the TFTP server has sufficient disk space to accommodate the image files. So a very good example could just a command show flash 0 command on your router to check the size. And we are doing this assuming that you'll be saving it within your router. So then you now copy the image to the TFTP server, okay? By, of course, using the copy command. So you say copy, put the source of the file, put the destination command. And after using that command, then the user, you will always be prompted, for the name of the source or the source file. You'll be prompted for the IP address of the remote device where you're going to save that particular file, and even for the destination name. And the transfer obviously will begin. So the command could go something like, copy from TFTP. When you copy it, when you save it on a device which is a TFTP server, I want you to note that you can also copy it back from that TFTP server back to another device that you want to restore. Okay, so if you want to restore it to a device, you'll just say copy, and you're going to copy the sources from a TFTP server, and the destination will be in a flash, for example. So you'll be required, of course, to put the name of the name of the device or the IP address, and that could be an IPv6 or IPv4. And then for the source file name, you need to indicate the source file name. Of course, that will be the image itself. And then you press enter, and that will definitely copy everything. So TFTP is very important for the sake of managing some of these files. You never know what will happen. Having a backup is just such a very, very important thing for our networks. And for this, I'll give you some few packet tracers again, just to allow you to be able to do some practice in this. So I think at that level we could end it there. And what I can do is that let me just give you some few assignments here to be able to learn how to manage some of these iOS files. And the commands are pretty simple. They're very straightforward to do that. So let me just log into my machine and open this page here. So so under network management, I will most of them are just packet trace activities. So so there's 10.1.4 is a syntax checker. There's a 10.1.5 for LLDP. There's 10.2.4 and there's 10.2.6 for NDP. There's a packet tracer here, 10.3.4 for SNMP. There's I think we don't have so much there. There's just a lab on 10.4.10. You could normally do some research for network monitoring. There's there's some very good created packet tracers here. There's 10.6.10. 10.6.10 is a very good one for you to be able to practice on, as well as 10.7.6. 10.7.6. And the last one is 10.8.1. 10.8.1 is a packet tracer that's going to combine all of them. 10.8.1. So the packet tracer one will just be something like this. Let me just open it here to just basically giving a brief description of what it's gonna be involving. So it will look something like this. Of course, I can just close that and this topology here. And so you look at, we have the NTP server is here, and there's the HQ router having two LANs here, and the HQ router is connected to the branch router connected to another network here. And so there's a couple of things that you're going to configure: CDP, configure LLDP, configure NTP server, and basically, if you can be able to do those the previous packet tracers and the syntax checkers, it should be able to basically give you a very good knowledge of how to basically work on these particular packet tracers here. So work on the syntax checkers, and the passwords and the enable secret passwords are all here for logging into these devices. So work on this, and this should give you a very good practice of what this particular activity is all about. Otherwise, I think that marks the end of this session, and we will meet during our next class. Which we will be talking about, just a minute. So during our next class, we'll be talking about network design. Network design is a very simple concept there. And a bit of network troubleshooting. Network design is basically optimizing the network. And network troubleshooting, we look at the troubleshooting methods available within the network. And we'll be having two very important concepts that we learn later on. We have network virtualization and network automation. These ones are key. But during our next class, I think we'll talk about network design and troubleshooting. Otherwise, I think this marks the end of this particular class meeting, and I will definitely see you guys in the next class.